Good day, everyone. I just want to apologize to you for the late upload of the modules in this course. It just so happened that I got sick and my voice was not that good for recording. And after that, my laptop was infected by virus and I need to back up all the files that were saved in it. It took me a long time to finish everything. I am hoping for your understanding. Happy holidays, everyone. The objective for the second course are as follows. First, you will learn how to design a 1-bit memory and then know how large memory is organized. And the third one is you will learn about the different memories and their individual advantages. To start with, I know all of you are very familiar with computer memory. This is used to temporarily or permanently store information depending on the type of memory. RAM or the random access memory stores temporary data, while ROM or the read-only memory stores permanent data. Each memory utilizes integrated circuits. And these integrated circuits are used by operating systems or system software as well as the hardware. A memory is a key component in computer systems. This will greatly determine the speed of the computer. There are two important parameters of memory, the speed and the cost. If you want to make faster memory, you need a sophisticated circuitry, and that makes it more expensive. So there are two operations in memory, which is the read and the write. If you want to store information or data into the memory, that is memory write. On the other hand, retrieving data into the memory is called a memory read. And these two operations are concerned with what is called access time. So how is memory used? So when a program such as Internet Explorer or Internet Browser is open, it is loaded from your hard drive and placed into the RAM. This process allows the program to communicate with the processor at higher speeds, and anything you save to your computer, such as pictures or video, is sent to your hard drive or storage. So why is memory important or needed for a computer? Each device in a computer operates at different speeds, and computer memory gives your computer a place to quickly access data. If the CPU had to wait for a secondary storage device, like for example a hard disk, a computer would be much slower. So people use memory or flash memory to store photos and documents. However, fewer people have asked how data on the flash memory are stored, and what a memory unit looks like, and why it can hold data without a need for a battery. So the figure shows one of Edison's great inventions, a light bulb. So when you turn on the switch K, the light will be on and will stay on. So when we turn off the switch, the light will be off and will stay off until it is turned on again next time. So now we see that the bulb and switch device can remember. But of course, the memory is not designed using a light bulb. Instead, a transistor is used. So the figure shows a circuit that uses transistor as an electronic switch. So the electronic switch or the transistor will turn on and turn off the switch. So when the input is low or 0 volts, so when the input here is low, or 0 volts, so there will be no current flowing from B to E. So therefore, the switch from C to E will be shut off and this will be disconnected. So therefore, the output will be high. On the other hand, when the input is 5 volts, so if you input here a voltage which is 5 volts, there will be a current flowing from B to E, and therefore the switch from C to E will be connected, and therefore the output flowing from this point up to this point will be 0. So the output here will be 0. So in designing a 1-bit memory, a traditional transistor-based electronic switch uses electric current to drive the component. So this is called a current-based component. Current-based component consumes a great deal of power that has heat problems and therefore cannot be made on a large scale. The next step is to use a metal oxide semiconductor or MOS. This is later replaced by a complementary metal oxide semiconductor or a CMOS component. So figure here shows a simple MOS switch. Among other advantages, a CMOS component theoretically consumes no current. It is a voltage-based component. When CMOS technology, a large number of circuits can be integrated into one circuit, and making large-scale integrated circuit as well as a very large-scale integrated circuit possible. So now, most of the processors are manufactured with VLSI technology. So among other advantages, a CMOS component theoretically consumes no current. So in designing a 1-bit memory, you need to connect two NOR gates. So this is called a flip-flop or an RS triggered. So the set S and then the reset R are inputs, and then the Q is the output, and that Q is the complement output. So there will be a separate discussion about designing of SRAM. So here, as you can see in the figure, a latch is a simple digital circuit where the output can be set to either logic 1 or logic 0 by an input signal. The circuit then remembers this state even after the input is removed. So this is a memory circuit that can remember a single binary digit, or what we call a bit. Circuits similar to this form the building blocks for a RAM memory that is used in all modern computer systems. So the 1-bit memory chip is composed of your input, the address or the chip select, and then the output, read or write. So there is also a special type of memory that is used to hold a binary value temporarily for basic calculations and storage. So we have here the registers, the MAR, MDR, and the main memory. Registers are a type of computer memory used to quickly accept, store, and transfer data and instructions that are being used immediately by the CPU. The registers used by the CPU are often termed as the processor registers. For a memory address registers or the MAR, this is a CPU register that either stores the memory address from which data will be fetched from the CPU or the address to which data will be sent and stored. The main memory in a computer is called the random access memory, which is popularly known as the RAM. This is the part of the computer that stores operating system software applications, and other information for the central processing unit or the CPU to have fast and direct access when needed to perform a task. The memory data register is used for holding information, either a program or a data, that is in the process of being transferred from the memory to the central processor or vice versa. Another type of memory is a cache. So this is a very high-speed memory. It is used to speed up and synchronizing with high-speed CPU. Cache memory is costlier than main memory or disk memory, but economical than CPU registers. Cache memory is an extremely fast memory type that acts as a buffer between the RAM and the CPU. This holds frequently requested data and instructions so that they are immediately available to the CPU when needed. Virtual memory, on the other hand, is a memory management capability of an operating system that uses hardware and software to allow a computer to compensate for physical memory shortage by temporarily transferring data from random access memory to the disk storage. A memory hierarchy of a computer system is shown on the figure. So on the top is the register where it has a quick access to the processor, followed by the cache where frequently used data are stored, and then the main memory, and lastly the secondary storage or the offline storage, or what we call the disk. So another type of memory is a non-volatile memory. So this is a type of computer memory that has the capability to save data even if the power is turned off. Unlike volatile memory, the NVM does not require its memory data to be periodically refreshed. It is commonly used by secondary storage or long-term consistent storage. The non-volatile memory keeps data even when power is removed. Flash memory and EEPROM are examples of non-volatile memories. External memory or the secondary memory is a high-capacity data storage. All of you are familiar with this type of memory. So the external memory is usually much larger than the main memory. The most commonly seen external memory is computer hard drives, USB flash drives, backup drives, and network storage are all external memory. In many cases, we refer to external memory as storage. Some external memory, such as hard drives, is connected directly to the CPU via the system bus. Some others, such as the USB flash drives, are connected via a serial interface. So it takes time to put together the address and data that is required to communicate with CPU, so it is usually slower than the direct connections. The hard disk drive is an electromechanical data storage device that uses magnetic storage to store and retrieve digital information using one or more rigid, rapidly rotating disks, or what we call the platters, which is coated with magnetic materials. The platters are paired with magnetic heads, usually arranged on a moving actuator arm, which read and write data to the platter surfaces. Data is accessed in a random access manner, meaning that individual blocks of data can be stored or retrieved in any order and not only sequentially. Hard disk drives are a type of non-volatile storage which retains stored data even when power is off. Another type of memory is what we call the tertiary storage or the offline storage. A tertiary storage or a tertiary memory is a level below secondary storage. Typically, it involves a robotic mechanism which will mount and dismount removable mass storage media into a storage device according to the system's demand. Such data are often copied to a secondary storage before use. For offline storage, this refers to any storage medium that must be physically inserted into a system every time a user wants to access or edit data. Offline storage can be any type of internal or external storage that can be easily removed from the computer. Offline storage is also known as a removable storage. The Serial Advanced Technology Attachment or SATA is a computer bus interface for connecting host bus adapters to mass storage devices such as hard disk drives and optical drives. Serial SATA was designed to replace the older ATA or the PATA standard, which is often called by the old name IDE. So it offers several advantages over the older interface. It also reduced the cable size as well as the cost with 7 conductors instead of 40. So it was also a native hot swapping, a faster data transfer through higher signaling rates, and more efficient transfer through an I/O queuing protocol. Another type of bus is the Small Computer System Interface or the SCSI. This is a set of standards for physically connecting and transferring data between computers and peripheral devices. The SCSI standards define commands, protocols, and electricals and optical interfaces. SCSI or SCSI is most commonly known as the hard disk and tape drivers, but it can connect a wide range of other devices including scanners and CD drives, although not all controllers can handle all devices. The SCSI standard defines command sets for specific peripheral device types, The presence of a DONE as one of these types means that, in theory, it can be used as an interface to almost any devices, but the standard is highly pragmatic and addressed towards commercial requirements. So another type of interface is the serial attached SCSI or SCSI. This is a communication protocol used to move data to and from the computer storage devices such as hard drives and tape drives. SAS is a point-to-point serial protocol that replaces the parallel SCSI bus technology that first appeared in the mid-1980s in the data centers and workstations, and it uses the standard SCSI command set. SAS offers backward compatibility with the second-generation SATA drives. The SATA 3 gigabits per second drives may be connected to SAS backplanes, but SAS drives may not be connected to SATA backplanes. For the components, so we have four types of component. We have the initiator, the target, the service delivery subsystem, as well as the expander. When we say initiator, this is a device that originates device service and task management requests for processing by a target device and receives responses for the same request from other target devices. Initiators may be provided as an onboard component on the motherboard or as an old add-on host bus adapter. A target is a device containing logical units and target ports that receives device service and task management requests for processing and sends responses for the same request to initiator device. A target device could be a hard disk or a disk array system. For a service delivery subsystem, this is the part of an I/O system that transmits information between an initiator and a target. So typically, cables connecting an initiator and a target with or without expanders and backplanes constitute a service delivery subsystem. For the expanders, this is a device that forms part of a service delivery subsystem, and it facilitates communication between the SAS devices. Expanders facilitate the connection of multiple SAS and devices to a single initiator port rather. So in addition, we also have the network attached storage. So this is a file-level computer data storage connected to a computer network which provides data access to the heterogeneous clients. NAS not only operates as a file server, but is also specialized for the task either by its hardware or software or configuration of those elements. It is also often made of a computer appliance, a specialized computer built from a ground up for storing and serving files, rather than simply a general-purpose computer being used for the role. The Storage Area Network, or the SAN, is a dedicated network that provides access to consolidated block-level storage. SANs are primarily used to make storage devices such as disk arrays, tape libraries, and optical jukeboxes available to servers so that the devices appear like locally attached devices to the operating system. A SAN typically has its own network of storage devices that are generally not accessible through local area network by other devices. The cost and flexibility of SANs dropped in the early 2000s to levels allowing wider adoption across both enterprise and small to medium-sized business environments. A SAN does not provide file abstraction, only a block-level operation. However, the file system built on top of SANs do provide file-level access and are known as SAN file systems or shared disk file systems. So cloud storage services may be accessed through a web service application programming interface or through a web-based user interface. I'm sure all of you are very familiar with the cloud storage. One example of this is the Dropbox. So cloud storage is a model of network online storage where data is stored in visualized pools of storage which are generally hosted by third parties. Hosting companies operate large data centers, and people who require their data to be hosted need to buy or lease storage capacity from them. So the data center operators in the background virtualize the resources according to the requirements of the customer and expose them as storage pools, which the customers can themselves use to store files and data objects. Physically, the resource may span across multiple servers. Cloud storage is made up of many distributed resources, but still acts as one. So this is highly fault-tolerant through redundancy and distribution of data, also highly durable through the creation of version copies, and typically eventually consistent with regards to data replicas. Another advantages of cloud storage are companies need only pay for the storage they usually use, as it is also possible for companies by utilizing actual virtual storage features like thin provisioning. Companies do not need to install physical storage devices in their own data center or offices, but the fact that storage has to be placed anywhere stays the same. Storage maintenance tasks such as the backup, the data replication, and purchasing of additional storage devices are offloaded to the responsibility of a service provider. So this allows organizations to focus more on their core business, but the fact that stays the same that someone has to pay for the administrative effort for this task. And lastly, cloud storage provides users with immediate access to a broad range of resources and applications hosted in the infrastructure of another organization via a web service interface. So because of this, we need to have protection on our data. So that's why we have the memory access security. A memory protection is a way to control memory access rights on a computer and is part of most modern instruction set computers and operating systems. The main purpose of memory protection is to prevent a process from accessing memory that has not been allocated to it. So this prevents a bug or malware within a process from affecting other processes and or the operating system itself. Protection may encompass all accesses to a specified area of memory. We have the right access or attempt to execute the content of the area. An attempt to access unowned memory results in a hardware fault, which is called a segmentation fault or a storage violation exemption, generally causing abnormal termination of the offending process. Many protection for computer security includes additional techniques such as the address space layout, randomization, and executable space protection. If an operating system can mark some or all writable regions of memory as non-executable, so it may be able to prevent the stack and heap memory areas from being executed. So this will help to prevent certain buffer overflow exploits from succeeding, particularly those that inject and execute code such as the Sasser or Blaster worms. So their attacks rely on some part of memory, usually the stack, being both writable and executable. If it is not, the attack will fail. So special thanks to Mr. Janel Hong, my master's student, a newly graduate BS Computer Engineering student from Catanduanes State University and now taking his MS in Mapua. He made this PowerPoint presentation as part of the requirements on Advanced Computer Architecture class. Thank you very much and have a great day.